Hello. Yes, so I'm going to talk exactly about that. I should thank Jerome Van Lannen, who's my colleague, who's actually done all the technical work. But he's on leave today. And Josh Jones, who's our customer, who's been very much involved, and I hope I'll kind of get that across today. So a little bit of, we're a consultancy based in Vauxhall who do apply models to solve problems, sometimes for big companies like Babcock, and sometimes for much smaller companies and charities as well, so it's quite varied. So a little bit about Babcock, who I think they're the second largest defence contractor for MOD, but they do an awful lot more. They're a huge company. They manage and control critical infrastructure facilities in the UK, and particularly what we've been involved with them is their port down in Devonport. So it's actually the kind of dock facility they run there and they own, which, as you can see, they deal with submarines. They are refitting, upgrading submarines and warships. So it's quite important stuff that they make sure they've got their facilities running and available. And they've got a lot of facilities, a lot of infrastructure. They've got their own bus network on site. So it's quite impressive. So this is Babcock's requirement. They are committed to digitally enabling its business for complex asset management. But particularly for us, they wanted to find a technology partner that could exploit their data to improve future investment decision-making for their critical infrastructure on the site. But when you get down into it, what they're really trying to achieve is they want an objective method to understand the current health of their dock assets, to understand the status of these things, and then predict how they're going to evolve in the future and fail. And then what do they need to do about that? Because they want to support investment decisions over the next 30-year planning period. Actually, Babcock run their port over 120 years planning because of equipment, future equipment purchases they envisage. But for us, they just limit it to 30 years. It's a bit more manageable. And they want something that's risk-based. And they want to consider the criticality, because you can imagine some of this stuff is really critical. Even small things, the knock-on effects could be super critical when the MOD have a submarine scheduled to come in for maintenance and their systems are not ready. And they wanted to use the current data or really minimize any new data we had to collect. And they wanted to make sure it would be that people who kind of audited this would approve the standards and approaches they took. And they were sensible. This is a huge site. They tried it on their 60 hertz electrical network. They have their own electrical network down there. So why us? Well, we've done work in this space, particularly in the electrical distribution. So Ofgem have kind of produced methods of how to handle reliability and the methodologies that they've come out with. It's called the Common Methodology. You can download it for free. I don't recommend necessarily reading it, but and we've implemented models of this for Northern Power Grid and allowed them to make investment decisions. And maybe more importantly, we worked with the Canal and River Trust, and we've made a similar-ish model for their whole range of stuff. And their range of items is extraordinary. So we're doing different bridges, the actual canal itself, locks, lock gates, aqueducts, reservoirs. It's just an endless. The buildings, SCADA, the control systems, trying to come up with a common methodology for all of that to allow them to invest there. They spend £120 million a year on investment. So it's quite serious amounts of money to help them do that. So that's why we were involved in this. And the approach we've taken, which is the approach we kind of always take, is to work with our client. And I think even if you're doing something internally in your organization, it's the same way. You'd have the modelers working with the experts. So we needed to understand the assets. So we're working with Josh and his colleagues, trying to understand their electrical assets, because that's not our skill. And then also they're gathering the information, the data, the hypotheses, the problems. And then we develop the model. And then we work back with the engineers to do the verification and validations. The question, are we building the model right? And then are we building the right model? Two questions that answers, is this right? And then we keep going round and round. And that's actually links to what Jakob was saying. It's quite an iterative process. And we do this on a 2-weekly cycle. We actually try to get into a 2-weekly cycle, sort of agile. And this is the assets we've actually worked with. So you can see it's quite bespoke. It's not what you normally get. It's large industrial scale electrical systems that are quite, some of it's quite unique, certainly deployed right at ship, at the shoreline. So it's kind of, the work we've done with Northern Power Grid is very statistical modeling where there's hundreds of thousands of these assets. You get data on failures. They've got 10 rectifier transformers. Hard to get data on that, so you have to use a lot more expertise. So 8 frequency changes and things like that. So it's quite, but that's the data, that's the asset, sorry. And then, I won't go into details of the model, but what I will talk about is how we work with the engineers. So we basically combined the 2 modeling elements. We've taken the electricity model for the electrical bits, but then adapted it for their particular, in fact, they've only got 8 rectifiers and they're all right at the sea. They're not inland as, trying to adapt that for whatever data we've got and their expertise, modifying that. And then from our Canal and River Trust, we're pretty good at understanding the housings and the buildings and that sort of things, which that is not covered by the off-gem approach at all. So that's quite, combining those together in a common framework, and then also understanding from the engineer. So they have to go out over their lunchtime and record all these things. It was a summer, last summer, so they were quite happy. A great summer. And then understanding how things degrade over time, and then other key input for the engineers is criticality. If this thing fails, what's the effect? What's the cost? You try to monetize everything, and then we go over a scheme to work out, based on probabilities essentially, what's our asset condition and what's the monetized risk. And then we talk to them about, well, what would be the triggers for you to make decisions? So the investment decisions, and then we can kind of optimize what's the cost of those investments and when should they best be done? So what becomes an optimization problem. Now, the output of this model, or this whole thing, is just a really long list of works, which is their investment strategy. It's it's very, very important. It's not very presentable, not very exciting, but actually there's something that goes on before that, which I think is much more relevant. They want to explore the scenarios. So they've got a budget over 30 years, their preferred budget, so we'll just call it X per year. And you can see they want, what happens if we just put it in a very even spend? We'll limit it to 105% of that annual budget. And let's see what happens in the model. And we can look at the risk within the system for the different asset types. And you can see the risk goes down as we start to invest. And then it starts to go up. And at some point, it can't. That investment means that the overall risk is growing in any one year. And that might not be very good news if there's a bunch of subs coming in and we haven't got the support there. So you might think, well, what about if we take away the constraint of this annual spend and allow some spend to be brought forward? So let's see whether we can keep the risk to within about 100%. If we double the limit per year, not the total is still the same amount. Can we adjust that? And you can see now we can get the risk within that 100%. And then you still think, well, could we, with the same amount of budget, be more flexible? And let's raise it to 3 times. Let's see what the model does to invest. You can see, so spending more up front, the overall risk is never more than 80%, with no more cost now. Okay, I guess you've got your net present value and things like that and involved. And you'll still see, well, there's still some risk growing in here, but actually, if you start replacing things too early, you've lost life in those assets as well. So it's trying to trade all of those different things going on. So, and then we can, what's quite nice is we've got all this data, we can then put it together. I think we spent about maybe 3 days making this tool, which works on a GIS. So it's, you can just see, we can look at you can see over time that it's going from light green to sort of red, and then we can look at the risk, that's health and risk, and so it's green, and we go over time and things get worse and worse. And then we can switch off different assets and focus in. So this is just bringing the data to life within the model for them. So there's another thing is we try to actually always give the model to the company. We don't run it, we just give it, we want a model they can use. So we can go in, engineers like this, that's an electrical circuit diagram, so they can start seeing the risk and the health at that level within it, and then click, and they can find out information. And when the model's thinking the different risks on that. So it's very interactive. very nice. So in summary, what we did for them, we worked really closely together. There was a lot of interaction, mainly over the phone and Skype and things like that. It's a long way down to Plymouth for a day. But that worked really well, and they were coming up to us as well. But we took an existing model, two models really, and put them together and applied them, and then lots of other open source things, and worked very closely. And we've applied it to their electrical asset types. I think they've got a lot better understanding of their assets and going into the future, and they've got an asset strategy that they're working with, and they were able to explore all those different alternatives. And what I just wanted to finish with was, well, okay, Babcock's it's a big company, but this same approach where you have a modeler working with the purpose and with the problem, the expert, is completely applicable, both internally and if you use consultants. So, and it's not just for assets. We do work in logistics and systems and defense security, lots of problems, and with different information. Here we had an actual very limited data was our challenge, but we had a lot of expertise. But in others, we do projects with Rolls-Royce, Royal Navy. We've got 120 terabytes of data, which is great. You can process that data. We've got with Southeast Water and with Food Standards, loads of data. So everything changes, but the process is still the same. And then there are lots and lots of different techniques developing the model. So this is mathematical and optimization, but there's lots more that have been talked about today. And then B&V, of course, but the outputs, the results, and the insights, the predictions, the sensitivities, the what-ifs. So I think this is that's how we make models as modelers, working together. Okay, thank you.